We continue our series with equations. This is part 11. We are going to rely on our rules for substitution that we did in chapter 7, but we're going to go one step further by making a set of ordered pairs after we've done the substitution. So in this case, the substitution, you will take one equation and you are going to substitute x with various or multiple values to get the y value. You're also going to have to take the y value, substitute into the equation, and determine the x value. We're now going to have another look at substitution, and in this case we are going to substitute in order to get some ordered pairs in a table. Let's just revisit chapter 7. Remember, we had the number machine. So whatever x, input was our x value. So if x was 4, it meant that I went 4 plus 7 is 11. Or x could be 10. So if x was 10, 10 plus 7, the output would be 17. If my input was 0, so 0 plus 7 is 7. So that was the number machine. Now we're going to progress to the table. So in other words, if x was 4, y was 11. Because remember, that's your x, this is your y. If x is 10, y is 17. So 17 would fit in there. If x is 0, y is 7. So that was what we did in chapter 7. Now we're going to progress to the worked example. So here it says the worked example, if y equals minus 3x plus 2. So they actually give you the equation. It says draw up a table, which we put underneath, of ordered pairs. We will get to this ordered pairs later. That's our final step, using the following x values. Right, they said to us x is going to be negative 3, negative 1, 0, 1, 3. So all we're going to do, we're going to fill those in at the top. The x is the independent variable, and y is the dependent variable, because y depends on whatever x's value is. So I choose, if you are independent, you can choose a whole lot of things. Okay, so if your parents think you're independent, you can make lots of choices for yourself. I always go in numerical order, so it's going to be negative 3, negative 1, 0, 1, and 3. Now I just want to recap from the previous substitution that we did. So it said if y equals negative 3x plus 2, calculate if x equals 10. And remember, we said that if you do substitution, you copy the pattern and you pop that in. So that is exactly what we're going to do here. So you can see I've written it nice and big over here. And I would do that in pen in my book and fill this little box just with a pencil. Then all you need to do is rub out the pencil. So you were told that x is negative 3. Okay, so x is negative 3. Where I see an x, which goes in this block, so I'm going to put negative 3. X is negative 3. And now all I do, rules of integers. So we say a negative multiplied by a negative is positive. 3 times 3 is 9. 9 plus 2 will give me 11. So that value is going to be 11. Okay, then all I'm going to do, I'm going to rub this out because now I'm going to change. So these are a whole lot of substitution sums. But remember, if I give you a table, all you have to do is do it once and you can do it in your head. So this time I'm changing the value of x. So x is -1. I'm going to do signs, numbers, letters. A negative times a negative is positive. 3 times 1 is 3. 3 plus 2 will give me 5. So when, oh my word, sorry about that. I don't know why it jumps around. So this is going to be 5. Let me try and do it in one brush stroke. Negative, it's going to be 5. Okay, now I'm going to change my x value, and that's why x is called a variable, because I can change it. And whatever I change it to is going to change the outcome. So the input is 0. -3 times 0 is 0. 0 plus 2 is 2. So when x is 2, when x is 0, y is 2. Now I'm going to fill in my 1. So when x is 1, a negative times a positive is negative. 3 times 1 is 3 plus 2. So -3 plus 2 will give me -1. This time, x has a value of 3. So all I do is I put a 3 in there, and I say a negative times a positive is negative. 3 times 3 is 9. -9 plus 2 will give me -7. So that is how we fill that in. But now, you also need to know how to work backwards. So, for example, they asked you to take these values, substitute into this formula, and get the y values. Now, what happens if I have a -28 here? Can you see these numbers are decreasing? So that's one way to check that you're on the right track. Okay, so now I have -28. The -28 is in the y line. So in other words, y equals -28. So I'm going to take my same formula. Just going to rub out here. Okay, so it doesn't confuse you. I'm going to take my same formula, which is y equals -3x plus 2. But in this case, it is y that must be substituted. So -28, remember we always substitute into brackets, equals -3x plus 2. And remember, no sign or anything outside means I've got a +1. A positive times a negative is negative. 28 equals 3x plus 2. And we spent the whole term doing equations. So this is an equation. Variables must go to the left. So variables here and constants on this side. So I'm only looking at this. This is my problem child at the moment. So I must -3x there, and I must -3x there. So I will have -28 minus 3x equals, we're balancing equations, a plus 3x minus 3x gives me 0. That's what I was planning to do. And then I've got 2 or plus 2. Right. I now have my variables on the left, but I now have to put my constants or my numbers on the right. So that is my problem at the moment. I must add 28 because -28 plus 28 will give me 0. But then I must also add 28 that side. So now we're going to write it nice and neatly. -3x equals 2 plus 28. So -3x equals 28 plus 2, or 2 plus 28 equals 30. X is connected by the multiply operation. So I divide by -3. Ka-chung, ka-chung, those cancel. But what I do to the one side, I have to do to the other. So I divide that side by -3. So x equals a positive divided by a negative is negative. 3 goes into 3 once. 3 into 30 goes 10. So x is -10, which I can then fill in over here. So when x is negative 10, y will be negative 28. So far, so good. Now, we are trying to put together ordered pairs. Okay? Ordered pairs is just a summary of your table. Okay, someone today in class said, oh, it's coordinates. You call them coordinates in geography. In maths, we're going to call them ordered pairs. So all I'm going to do, I'm going to add another row, and I'm going to write ordered pairs. And over here, I'm going to fill them in for each column. So when I look at this, let me just, okay. So when I look at my ordered pairs, from this, I have to have an ordered pair. And remember, x comes before y in the alphabet, so it's always x value, colon, y, and they're always written in brackets. So all I do here, my x value is negative 3, and my y value is 11. So this tells me when x is negative 3, y is 11. My next one, x is negative 1, so this is your x value. Your y value is 5. It has to have brackets around it, and it has to have a semicolon in between. This one, x is 0, and y is 2 in brackets. X over here is 1 and y is negative 1. X is 3, y is negative 7. So we know, just like we know if I write the number 4, it has an invisible plus. When I write an ordered pair, I know that this is the x value and that is the y value. This one would be negative 10 and negative 28. This should have actually come way before over there. Right, your homework today, I need you to do 1A and then 2 ABC. This one is real life maths based on ordered pairs or equations, and that's on page 118. So page 118. And it's exercise 8.11.